Welcome to Season 4, Episode 9 of Tech Talk Thursday. This week we take a look back at Q3 and some of the main stories affecting the EMS industry. One of my favourite interviews in Q3 was Dave Torp, who has recently taken over as President and CEO of Additive Circuit Technologies. ACT comprises a small group of companies that have pioneered a laser direct imaging process for producing high quality PCBs with very high dimensional accuracy. I asked Dave what the current limitations of the system were.
A traditional standpoint, we're comfortable with the 25 micron lines and spaces at this point. The pushes with the laser imaging that the capabilities are, we're looking to push down to 15 micron lines and spaces throughout the course of this year, and then in the next year we're going to get crazy and try to do something on the order of 4 micron lines and spaces. Wow. Can't promise anything, but that's where what we are defined by is at laser definition. Yep. And how those lines can be laser defined, but that's the only, at that point, that's the limiting factor right now. And there's some very good partners we have in the in that space, some equipment partners we have in that space who are helping us out and kind of getting that process dialed in. And in addition, for what I'll call a current state-of-art printed circuit board shop, to get the resolutions is one thing on the laser definition, but you also have to be able to laminate it. Yes. Okay, you also have to be able to drill those holes. Okay, because on a 4 micron line or whatever, it's the hole size becomes challenging, and the plating becomes challenging, and the etching becomes challenging. So there's a whole symphony that needs to be conducted on the manufacturing floor in order to get product generated that's capable product. So that's where we're upgrading. We're making a multi-million-dollar investment into state-of-the-art equipment so that the rest of the process can keep up with the laser defined features that we can do.
We also had a range of panel discussions in Q3. Here is an excerpt from the panel on automating the automatic inspection process, where I asked Brad Ward about the best approach to inspecting shiny devices.
Well, nothing's shiny to an X-ray, so that's one strategy for sure, right? But
you can't always go to the X-ray, Brad. It's too slow.
Well, I disagree. I think you can always go to the X-ray. Yeah. So let's take X-ray out of that equation, because that one's literally black and white. Not to joke, but yes. So if we look at shiny objects on the AOI side, there's so many varied degrees of shiny and what shiny means. Shiny could mean something like a silicon die. It could mean something like a lot of connectors have shiny housings that are grounded, things of that nature. Could be LEDs, and all the thousands of varieties of LEDs that are out there that have shiny-ish diffusers and lens on those things. So
So having established the many different types of shiny devices, Detlef Beer, Head of Product Development at Viscom, offered recent guidance from Texas Instruments on how to create rough surfaces on shiny components.
Here really is this kind of component where you have now here this kind of frames, and especially here in the description it is that here from the complete knowledge you see that is in this case the light not maybe reflected more in the standard way. So that means that you really have issues for your AOI inspection. So that is something where you should keep in mind when you test it, that you must run here different test strategy. We tested this component, and with 3D is working well, but with the standard 2D approach, it was difficult.
So what you're saying is that the light is not diffracting off of the device in a linear motion. It's actually hitting off of it and going in all sorts of different directions.
Ramon Hernandez from Co-Young offered a similar suggestion, but using markings already on the component surface.
Shiny components are challenging. It's not as straightforward as a different component, and we can see in the semiconductor industry, right, with the die components, most of them are really shiny components, just like a mirror. And in some cases, even though we see these components are shiny components, at algorithm level, there's always either scratches, OCBs, OCRs that will help the system to identify the surface of the component. But in the other hand, we have really polished surface components or even transparent surface components. And in that case, you need to play with the calibrations, with the lightings, maybe angles of the lightings and everything. So it becomes a different world, and it depends also on the product that you will recommend, one model of your systems or a different model that will fit the customer production, customer demands.
So if I understand you correctly, what you're saying is you play with or you alter the lighting to try and pick up the different characteristics inside the shiny joint, whether that's a scratch or something like that, that you can then use as a reference point.
Correct.
In recent weeks, we turned our attention to the many issues around the global supply chain crisis. This has sparked an increase in the number of companies using automated component sourcing systems. I asked Steve Vecchiarelli from CalcuQuote exactly how these systems work.
Most of the suppliers that we're hooked up with give us an API, and for those that don't know an API, it's an application programming interface that puts us directly into their system. So via the API, we're able to look in a lot of cases real time at their inventory and their pricing. So at 11 o'clock on a Thursday morning, XYZ supplier had 10,000 of these widgets and they want $1 each. Then they can make their buying decision to buy it or not. It's all, in a lot of cases, it's all real time. So if they go back tomorrow, that inventory may not be there because, they supply real time data. But it gives them an idea of what's in the marketplace. And depending on what systems that they use and what they use from CalcuQuote, they can place orders real time right there, or if they continue, they can place orders however they place orders. But they know that at that point in time, that was what that supplier had.
And finally, we held a town hall debate on this very topic, and Mats Holtzman from CGI Americas explains the problem expands well beyond a shortage of chips.
Well, the semiconductor manufacturers have all committed to massive expansion. So they're talking about expanding fabs in Europe and North America and expanding fabs in Asia as well. So, as is typical, I think we're going to find that moving forward, there's a lot more fab capacity, and there may be more than is needed, but we're also moving towards much more sophisticated chips. So the 3 nanometer node is now being discussed for North America. The 5 nanometer is probably going to be a standard. as time goes on, and then you'll have all of the less complex chips that are still being manufactured that are going to go into much less sophisticated applications. But at the same time, we do not have the capacity with the assembly and test houses and the printed circuit fabricators and all of the other suppliers that is distributed locally. Distributed locally, because so much of this has been resident in Asia for so long.
Richard Boyle from Henkel went even further, expecting the global disruption to be with us for some time to come.
With the rapid increase in changing cars from standard internal combustion engines to electric vehicles, the number of electronic products and therefore the number of chips and the number of components required in those is an exponential growth. So it's not only a case of, there's a shortage now, but as more and more companies change from building standard cars, if you like, to electric vehicles, and that's the same for trucks and vans and everything, this problem's only going to get worse. The number of sophisticated chips and basic components in all of those vehicles is exponentially more than it is now for standard cars. And that trend is going to be the same for industrial products and lots of other things that are being developed and produced now. So it's not just an issue we've got now, it will be an ongoing issue for quite a long while.
Well, that wraps up our roundup of what happened in Q3. Q4 is going to be an amazingly busy quarter. We have a number of major physical and virtual events ranging from SMTAI at its new home in Minneapolis, Productronica in Munich, eSmart Factory virtual in early December, and Semicon West, which is also being held in December. We will also continue to bring you a string of expert panel discussions and, of course, our weekly Tech Talk Thursday interviews with the great and the good. Join us for all of the above. Until then, this is Trevor Galbraith saying thank you for watching.
Global SMT and Packaging opens the windows of the world to bring you the latest news and technologies from Munich, from Bangalore, from Shanghai, from San Diego.